Good morning, my dear friends and my dear viewers. Today I am here to give a presentation on effect of subcooling on VCR systems. To understand this, you should be very relevant with your topic of refrigeration process. To understand this, first you need to understand what is refrigeration. Let's start with understanding what is refrigeration. Coming with refrigeration. Refrigeration is the process in which heat is taken out from the system. Heat is removed from the system by by absorbing all the heat from the system. That is absorbed by a liquid flowing around it. That is called refrigerant. When we pass a refrigerant flowing liquid inside the system which absorbs all the heat, and that refrigerating fluid again gets converted into vapors. This How is this process going to happen? We are going to study now this refrigeration, starting with refrigeration cycle. To understand this refrigeration cycle, we need to know the basic components of refrigeration. Refrigeration happens with four basic components. Let me go with basic components of refrigeration. uh, First thing involved here is compressor. We have compressor in refrigeration, evaporator, and condenser. What is, I'll just let you know what is the basic functionality of this. First, coming with compressor, which increases the pressure of the fluid, that is refrigerating fluid, which increases the pressure of refrigerating fluid. Now coming to condenser condenses. Condensers means when you have heat is supplied to this, it makes down the temperature of this system. That is the functioning of condenser. What is evaporator? What happens is liquid in this is taken and it is converted into vapor form. That is the functionality of evaporator. And now let's understand what is difference between a refrigerator and a heat pump. Refrigerator and heat pump are analogous to each other. What that is, that considers with our subject here. What is our heat pump and refrigerator? The difference is both of them are working in two different heat temperatures. Lower temperature, TH is the higher temperature, TC is the lower temperature. Both of them works in two different temperatures. But the major functionality here in the heat pump and refrigerator is heat pump. As you all know that heat pump transports the water from lower point to a higher point. That same functionality is also considered in heat pump. Heat pump also takes heat from lower temperature and throws out to its higher temperature, so that your temperature in the lower level remains condensed, like that is on your lower side of that temperature is very low. That is the functionality of heat pump. That same is refrigerant. Now what is the difference between heat pump and refrigerator? What happens in the heat pump? I'll show you a diagram of this. Now let's speak about refrigeration effect. What is refrigeration effect? Refrigeration effect is defined as the quantity of heat extracted from the cold body, or the cold from the what do you say, your space, amount of heat extracted per total time taken. How much is the time taken to extract particular heat? That is called refrigeration effect, and that is denoted by a letter N. Then let's speak about what is specific heat of water and ice. As we are considering the benchmark, what we consider the specific heat of water and ice. The specific heat of water is defined as the quantity of heat required to raise the lower temperature of 1 kg of water to 1 Kelvin is defined as the specific heat of water. That is, specific heat of water is given by specific heat of water is denoted by CPW. CPW is equal to 4.19 kg kilojoules per kg. Specific heat of water is given here. You can see here. A specific heat of ice is also given 2.1 into kilojoules per kg Kelvin. And now we'll see capacity of refrigeration. When we discuss about refrigeration, what is the capacity? People ask you what is the units of refrigeration, how much is the quantity, capacity. Then people take this units in terms of tons. How much ton? Like suppose you might be heard of this ton in your refrigerating units also. Suppose some people tell this complete room requires 1 ton of AC. That is, refrigerating capacity is taken in terms of tons of measure. as it is mentioned same here, capacity of refrigeration as expressed, that is called cooling capacity. Your refrigeration capacity is similar to cooling capacity. And what is 1 ton of refrigeration? 1 ton of refrigeration is defined as the quantity of heat abstracted to freeze 1 ton of water, is defined as 1 ton of refrigeration. And duration taken for this 1 ton of refrigeration is 24 hours. That is also taken in consideration. That is your 1 ton of refrigeration, how much time it is taken, like how much heat required, heat extracted divided by total time, that is 24 hours, 1 day, that is particular. Now we'll see what is coefficient of performance. To speak about coefficient of performance, like in our motors and everything, we measure what is input by output, that is efficiency of this. But when it comes to refrigeration, here pumps refrigerator is measured in terms of coefficient of refrigeration, that is its efficiency is particularly taken as coefficient of refrigeration. Coefficient of refrigeration is defined as heat extracted in the given time, that is heat extracted by work output. That is, coefficient of refrigeration is given by heat extracted in vapor in evaporator divided by work input. How much is work input given? That is refrigeration effect by work input. That is N by W. And now let's speak what is refrigerant. Refrigerant is a substance or a liquid that flows to cool down the system. That is called refrigerant. Now let's go with definition of refrigerant. Any substance that absorbs heat through expansion and evaporation process, and the losses heat due to condensation is refrigeration process, is called refrigerant. I'll come with a simple one. So what is this refrigerant is, when you are trying to cool something, you supply a liquid which revolves all the surroundings of that. So that liquid is called refrigerant. That refrigerant, or of ammonia refrigerant, air refrigerant, CO2 carbon dioxide refrigerant, methyl chloride refrigerant. We have different kind of refrigerants. You have refrigerant is again classified into 2 types, that is primary refrigerant and secondary refrigerant. To speak what is primary refrigerant, here what primary refrigerant is, it is working medium which is used for cooling the substance by absorbing latent heat. This is basically when you have a heat, or when you initially supply some refrigerant to take out the heat, that is called, the initial one is called primary refrigerant. If the heat is not still released, if you still want to extract the heat, then we even supply secondary refrigerant. This is called secondary. Secondary refrigerant is substance which is already cooled by primary refrigerant. Again we cool that substance, that is called secondary refrigerant. Now what are these types of refrigerant? We have 3 types of refrigerant. Refrigerators, not refrigerators, sorry. Refrigerators are of 3 types, that is ice refrigerator, air refrigerator, vapor refrigerator. Basically these are divided based on their working fluids. Here in the ice refrigerant, you have the working fluid is ice. By using ice, the substance inside that is cooled, that is called ice refrigerator. Again one more is air refrigerator. Air refrigerators are basic one. What do you say, this Bell-Coleman cycle, that is called air refrigerator. And one more is vapor. Our working fluid is CO2, that is carbon dioxide, ammonia, SO2 are working fluids. Now let's speak what are industrial application of refrigeration. Refrigeration, as we all know, we use for cooling our normal food eatable items, to preserve that we use it. As in the similar way, even industries has lot of these applications of refrigeration. So let's speak few applications of refrigeration. Majorly in the chemical industry, we have like separation and liquefying of gases. There also, like what happens in your petroleum industry. You know that petroleum, have you ever touched petroleum? Petroleum is it has a least what do you say, it has a very low temperature. When you touch it, you can feel that it's always preserved on very low temperatures. So that has to be preserved on this low temperature. So that is used in chemical industry. Like, and even like when we speak about this thing, cooling towers, even there we use refrigeration. We have many applications of refrigeration. When you see like in your in-orbit malls, we require refrigeration. That is also a major application of refrigeration. Now coming to our main point of this, let's understand what is vapor compression refrigeration system. By listening the word vapor compression refrigeration system, what do we understand? Like, coming to our schooling knowledge, what is basic vapor? Vapor is a process in where evaporation happens, then we get vapor. That is the basic point. So like what are we going to use? Just we need to get on point. We are going to use vapor evaporator. That is our part here. Let me once I give you a briefing, then I'll explain you each and every functioning of each part of that. And again, coming to compression. What is compression? Actually, compression is a new term. We have never heard this before. Compression is we are going to compress the air, like we are going to increase the pressure of air. That is called compression. Again, what is refrigeration? Still we have been discussing what is refrigeration. So refrigeration, we know it is the process in which we cool or we decrease the temperature of surroundings. That is our refrigeration. Now let's come to each and every parts involved in the system. So coming to parts involved in the system, first thing is condenser. We have condenser here. Again, what we have is we have capillary tubes, we have evaporator, and we have compressor. Just once let me explain you working of this, then I'll explain you each and every part what is working upon. See, what happens here is basically this is the working diagram of our vapor compression cycle. So what happens is here in this tubes, you are able to see my cursor. So here what happens in this tubes, we have liquid flowing, that is refrigerant. What happens is refrigerant flows along this. So this is your capillary tube. This is your capillary tube, and the path where this starts from, this is the point of compressor. Let me explain what is the functionality of compressor. Compressor is used to pump your refrigerant, your liquid flowing. It pumps your liquid from low pressure to high pressure. It increases your pressure. So here it is increasing your pressure. So your liquid refrigerant, what is flowing, it is flowing in this way. Again, it is coming to compressor. This point, this here, it is compressor. This is a compressor and this is condenser. Sorry, this is condenser. What condenser does is, like if you have some vapor form of that, vapor form of your refrigerant, it converts into liquid form of that. Basically, function of condenser is to change your phase of your refrigerant from vapor phase to liquid phase. In this phase, it converts from vapor phase to liquid phase, and now it is moving here in this pipe. Once it is reaching to your expansion wall, before it reaches to expansion wall, it is what happens in expansion walls is your pressure, like certain required pressure it needs. It's very high pressure, like coming out from that condenser. So to decrease that pressure, expansion wall, it decreases the pressure of that. Once this pressure is decreased, it enters into your evaporator. What is your evaporator functionality is? Your evaporator like changes the phase. Again, what happens? Your liquid from condenser, you're leaving the refrigerant in the liquid phase. From liquid phase, again it transforms into vapor phase. So once it is transformed into vapor phase, it circulates all around your cooling surface. Once it circulates all around your cooling surface, what happens is your surroundings, what has to be got cooled, it gets to a particular cooling level. Once it is brought, again this pipe, this is again recycling point, it again comes into the compressor. Again, what happens is once it is cooled, it transforms that phase, pressure decreases. Again, it needs a higher pressure. To get this higher pressure, again the compressor, this is a reciprocating type compressor, so it again increases the pressure of that. Once the pressure is increased, see here the same process is defined. Here what happens is your numbering also is given from 1 to 2. The refrigerant flows from 1 to 2. So that what happens is refrigerant need to be pumped. So it enters into the compressor. So what happens is compressor pumps the refrigerant. So once it is pumped, so it goes to condenser. What is the functionality of condenser? Condenser is liquid vapors are condensed into your liquid form. Then once it is formed into liquid, your expansion walls, it goes into expansion wall. What happens in expansion walls is pressure is too high towards the condenser. So what happens is it decreases the pressure and it gets sent into evaporator. What evaporator does is that same liquid, it is in the liquid form. So it evaporates and tries to evaporate, and then the phase of refrigerant changes to your vapor phase. Then it is pumped into the compressor. This same cycle repeats and repeats. You get refrigerating effect. Once this flows around, you will get refrigerating effect. Now, in the same way, we are going to study this temperature and entropy diagram. So, what is this temperature and entropy diagram states is on your right side of your this thing is your saturated vapor, and this side is your liquid. Your vapor is on your right side, and left side is saturated liquid. So, what initial stages? What happens is your 1 to 2. So your temperature is increased. So 1 to 2. Again, from your 2 to 3, what is your 2 to 3? So it enters into your condenser. So once it is enters into your condenser, what happens into your condenser? Your condenser liquid changes its phase. That is your vapor to your liquid. So here there is some temperature drop. So your temperature is dropping. That is stated in the graph. Again, your 3 to 4. So it is going to expansion wall. So expansion wall, we are just there is a pressure change. So temperature is same. So temperature remains same, constant. Again, when you're going from 4 to 1, evaporator. So what happens in your evaporator? Your evaporator, your liquid changes its phase. That is from liquid phase to vapor phase. So there is some temperature increased. So here this is so similarly enthalpy also increases. 4 to 1 defines the same point. Entropy change. This is like now we'll discuss like deep into this. What is vapor compression? About the cycle we'll discuss. Coming to this vapor compression cycle. Now we are discussing the construction of this. This happens with I already discussed the major parts of this. We have a compressor. Compressor. What kind of compressor we have? We have reciprocating type of compressor. For very big plants, centrifugal compressor is directly coupled with this. But like most probably we have reciprocating type compressor. And next major part is we have evaporator. Let me change the slide. This one is your centrifugal type compressor. Basically what happens is like these are used in very big plants like cooling towers. When you have air turbines rotating, so you have to cool those surfaces, then we use centrifugal type compressor. Then like what are major parts, construction parts involved here? We have expansion wall. Expansion wall is here for high pressure refrigerant is made to flow this thing so that you can decrease this pressure. The major part here is used, evaporator used here. Now let's come back to our point. What is our point here is effect of subcooling on VCRS systems. So to understand this effect, so first we need to understand what is subcooling. Subcooling is defined as subcooling is the process of cooling of liquid refrigerant below its condensation temperature. What that means is the liquid refrigeration. Like the liquid refrigerant goes into inside the compressor. It goes inside the compressor. Again, it goes inside the condenser. So what happens is the liquid then converts into vapor. So when it converts into vapor, we are getting it back into liquid form. To get into its liquid form, so we are going to get it into its liquid form by making its temperature. Cooling its temperature from its vapor form to liquid, we are cooling it and getting it to its temperature. This phase is called subcooling. So now let's understand how this is concerned with the effect on VCRS system. As we have already seen VCRS system, let me just brief you some this VCRS system. So what are the basic parts of VCR systems are? That is compressor, condenser, evaporator, and your metering valve. Metering valve is your expansion valve. Here is the schematics of your VCR system. So what happens is your liquid flows here, then it goes into your just a minute, it goes into your compressor. Once it is compressed, your fluid, then it goes to its superheated vapor form. So once it goes to its vapor form, it then condenses into its liquid form. This is the place where subcooling happens. So now let's see this using temperature and enthalpy graph. This is your illustration of subcooling. Subcooling, here it is given, it is the amount of heat removed from the refrigeration after it is already being condensed, the liquid. Once that is condensed, the heat is removed from the refrigerant also. That is called subcooling. So here we have phase diagrams of this subcooling. So what happens is this is enthalpy and this is your temperature. So like this diagram, here it is given 1 to 2. What is your 1 to 2 phase is your compression cycle. Then again comes to your 2 to 3 is your condensation cycle. Then again comes from 3 to 4 is your evaporation cycle. Then 4 to 1 is your 3 to 4 is your expansion cycle, that is wall pressure drop, like your what do you say, expansion wall of that. 3 to 4 is your that expansion. Then again 4 to 1 comes your evaporation cycle. Then we'll see the degree of subcooling. Degree is the amount of subcooling happening inside, is defined as degree of subcooling. Degree of subcooling is defined as the saturation temperature of refrigerant minus the temperature out of the condenser is defined as the degree of subcooling. This is the compressor, this condenser outlet temperature must be measured through thermostat or thermocouple. It should be measured with thermocouple. Now we'll see the effect of subcooling. The effect of subcooling is on two types. That is a refrigeration effect is increased. your refrigeration levels is increased, and again COP of your refrigeration also increases. Let's study this by analyzing the diagram of this. See, here is your pressure and enthalpy graph. So when you see your subcooling goes on your left side, so your 3 becomes 3 dash and 4 becomes 4 dash. So now we are VCRS system, what we are going to consider is 1 2 3 dash and 4 dash, because of our subcooling is on our left side. So your graph comes on your left. So what is your subcooling levels is towards your left side is. Now coming to work done by the compressor. Just now what we have heard, that degree of compression, that is your initial stage, H2 minus H1, that is your work done by the compressor. Now again RE is equal to, as similar, H1 minus H4. Then what happens, what is the effect of subcooling? Here we are coming on the point. When your subcooling happens, your RE increases simultaneously, and your mass flow rate also increases. As your mass flow rate increases, RE also increases, and your this thing, your entropy also increases. Once your entropy increases, your RE increases. As your RE increases, coefficient of COR, coefficient of your pump also increases. So this is the effect of subcooling on your refrigeration cycle. Thank you.